already online. Those numbers are good clues of your interest for our webinars about open source tools for the management of geographical names. There are also a testimony of your satisfaction for the previous one in last May about the development of gazetteers and web services using free and open software. This confirms the relevance of our strategic aim to raise awareness and build capacity on the use of technology and innovation within the UNGEGN community. I would like just to thank in advance each of the experts who have agreed to share their experience and expertise in this webinar, either as a presenter or as a moderator, Pierre Giorgio. I rely on the technical expertise and teaching ability to make this webinar fully useful to all of us. Thank you for your attention. And I leave the floor to Stefan.
Okay, good morning from New York. Hello around the whole world. My name is Stefan Schweinfest. I'm the director of the UN Statistics Division, where the Secretariat for the United Nations Group of Experts on Geographical Names is hosted. And it's my pleasure, thank you, Pierre Jaillard, the elected chair of the group, for giving me this opportunity to welcoming you on behalf of the Secretariat, in particular Cecile Blake, who is connected here and many of you know, and who is the, I would say, the heart and the soul and the driver here in the Secretariat of the group worldwide. This is the second UNGEGN webinar. We had defined a series on current and relevant topics as part of the strategic plan over the next couple of years that the group of experts had defined. And in a way, the webinar or webinars in general are perhaps at least one small positive outcome of the pandemic period that we've just been living through, where experts across the globe are able to meet and connect in a virtual place. And I see the numbers going up, and there are many connected from many different places at this very moment. So I thank the organizers, in particular the members of two working groups, the working group on geographical names and data management, and the working group on training courses in toponymy, for putting this together and organizing this event. It is a highly relevant topic. Open data, linked open data is a new paradigm enabled by, of course, the internet. It is a new philosophy of providing access to information, and it's a new philosophy also of good governance, I would say. So I wish you, we have interesting speakers. I wish you a productive and interesting hour and a half of exploring this topic. And let me conclude by inviting you to come to our UNGEGN session. The forthcoming UNGEGN session 2023 will be held in New York at the United Nations headquarters from the 1st to the 5th of May. It will be an in-person meeting, and I hope we will be able to welcome many experts from around the globe. Thank you very much for connecting, and I give the floor to our moderator, Pier Giorgio Saccadu.
Thank you very much, Stefan, and thank you very much, Pierre, for this kind introduction. My name is Pier Giorgio Saccadu. I'm the convener of the working group Geographical Names Data Management and the German representative within UNGEGN, and I have the pleasure to moderate this session. And before we start, you see already my screen, which I share, where we have put some rules together. You might all know these rules, but I will just briefly go through them. So when you're not speaking, please mute your microphone. I can't hear any noises, so that has already happened. Please keep your video turned off unless you are speaking. Also for that, yeah, that would be good to keep the bandwidth as strong as possible. If you have any questions or if you would like to ask questions or to provide any comments, please use the chat. I will monitor the chat and will refer to it at the end of our session. Silence your cell phone so that you are with us and full concentrated. And I would like to mention that the webinar will be recorded, so that's a big advantage that afterwards you can share the content even with others who were not possible today to attend the webinar. So I have, as I said, the pleasure to introduce the speakers. I will do that immediately. We will have then 45 minutes of presentations and have foreseen some time also for questions and answers. And then my colleague, Susan Bertels from Australia, will have some closing remarks. Well, I'm the moderator. I introduced myself already. The first speaker will be Henrik Askjær. He is IT developer at the Norwegian language collection at the University of Bergen, with the responsibility for geographical names services. He has been instrumental in the development of the collection's latest linked open data geographical names portal, the Norwegian place names, and Henrik is trained as a historian as well as in IT. He's originally from Westfold, south of Oslo, but is now residing in Bergen. The second speaker will be Alexandra Rowland. She obtained a Master of Science in Geographical Information Management and Applications from the University of Utrecht, the Netherlands, in 2021, and based on the thesis proposing a methodology for automatic GIS workflow generation using semantic technologies. Following graduation, Alexandra joined Cadastre, the Netherlands Land Register and Mapping Agency, as a PD engineering student and is currently supporting the ongoing development of the Cadastre knowledge graph and the development of the metadata infrastructure using semantic technologies. The third speaker will be Falk Wührihausen from my agency in Germany. He has received his PhD in geoinformatics at the University of Rostock in Germany in 2016. After the doctorate, Falk started to work in the Federal Agency for Cartography and Geodesy here in Frankfurt as head of a standardization working group in the coordination office from the spatial data infrastructure in Germany. As part of his work, he has been the lead of the Linked Open Data project in Germany from 2019 to 2021. And in this webinar, he will present some results of this project. The last speaker will be Peter Gammeltoft. He's the scientific manager of the Norwegian language collection at the University of Bergen, overseeing the curation of the collections and development of the Norwegian language services. He's currently working group convener in UNGEGN and the Norwegian representative to the group of experts. And Peter was formerly associate professor in name research at the University of Copenhagen, the head of the Danish place name committee and representative of Denmark. These will be the speakers, and as I said, the closing remarks at the end will be given by our colleague Susan Bertels from Australia. So I hope that you will enjoy the next 45 minutes of presentation, and I would like to give the floor then to Hendrik. But before that, just to know for you that at the end of the webinar, the participants will be asked to complete an evaluation form, and the link will also be posted in the chat and is here on the slides as well. So Hendrik, if you are there, you have the floor. I will stop sharing my screen now, and you can take over.
Thank you very much. Just a couple of seconds. Yeah, I've been asked to give from Adam and Eve introduction to linked open data. And as a historian turned software developer, I was tempted to go as far back as antiquity, but since I only have 15 minutes, I will limit myself to trace the origins of linked open data back to Tim Berners-Lee's proposal for the World Wide Web in 1989. Tim Berners-Lee envisioned a web of links between nodes representing not only documents, but people, projects, concepts, etc. And in other words, he envisioned a global interconnected database, a web of data. After he implemented the HTTP protocol and HTML, hypertext and the linking of HTML documents was what caught on and became an integral part of the internet we know today. Berners-Lee never abandoned the dream of a semantic web, and the World Wide Web Consortium that he founded developed a series of standards for metadata transfer on the web in the late 1990s called the Resource Description Framework, RDF. RDF is a framework both for instance data, that is information about individual things, and ontologies, that is schema that describe types of objects, relationships, constraints on these relationships, etc. Later extensions to RDF, such as the web ontology language, further facilitate creating such ontologies. The RDF model differs from the relational model in traditional databases, where rows are connected across tables using identifiers that are unique within each table. In the RDF model, on the other hand, data is represented as a graph structure composed of triple statements of identifiers that are unique across all databases, using URIs that are a superset of URLs, web addresses. To illustrate this, I'll show you an example of data in a format based on the RDF standard, where identifiers in the triple are enclosed in angle brackets and separated by white space. In this example, I've used a relationship or a property that I've defined myself in this example, and I've used it to connect two instances from Wikidata representing the United Nations and the concept of an international organization. So this triple represents the statement, the UN is an international organization. A triple can also contain raw data. So the the third element in the triple does not have to be a URI. It could also be a number or a textual description. Like in this example, the UN was established in the year 1945. This data, or the literals, become the leaf nodes of the graph. In the example you see here, you might notice that the triple data does not include all the data all the information we get from the graph. So if we were to include the labels in this graph, we could add them using an extension of RDF called RDF schema, and add the label the UN to the first entity, and we can add the label established in the year to the property that I defined myself. And this would be a part of the ontology. Furthermore, I could state that the UN identified by Wikidata is the same as the UN defined by another source, by using a property from the web ontology language. RDF paved the way for linked data, a term coined by Tim Berners-Lee in 2006, when he proposed 4 principles or ideals for publishing data on the web. The first of these principles was to use uniform resource identifier that I've already talked about. Nowadays, it's also often referred to as IRIs, because they have been extended to include Unicode symbols, but it's a superset of URLs. So all URLs are a URI. His second point was that these URIs should be HTTP URIs, so that people can look them up on the web, and when they look them up, you should provide useful information using an open standard such as RDF. And finally, you should include links in your data to other people's data, URIs in other people's data, so that the data becomes interconnected. Since 2006, new innovations have realized more of the potential of linked data. One example is Sparkle, which is a query language for RDF created by the W3C in 2008. Sparkle endpoints are systems that allow external developers or users to query a database directly without having to request a data dump or use a predefined API. So they are more free to explore the entire data sets on their own terms. Sparkle also makes it easier to write complex queries and find answers to questions that would be very time consuming to do manually. I hear someone has their microphone on, so I hear some feedback. Right. Sparkle endpoints are built on top of what's called a triple store, which is a graph database purpose-built for linked data. Some of the challenges with this technology is, for one, scalability, stemming from the fact that URIs take up a lot more space than integers that are often used as identifiers in relational databases. And we also suffer from a lack of expertise. Most developers are familiar with SQL and relational databases, if not everyone, but the same cannot be said for Sparkle and graph databases. One of the advantages of triple stores is that it has the flexibility of the RDF data model. You can add heterogeneous data without having to alter a database schema like you have to in a relational database. Of course, you would want to validate and streamline your data by defining an ontology, but it is possible to transfer data directly from one database to another without changing anything. Joining data also becomes very efficient in a triple store, much more so than in relational databases. And finally, a triple store enables reasoning, that is referring facts from existing data in the database. If we talk about linked open data in general, with emphasis on open, then some of the challenges will obviously be linked to privacy, as well as legal issues concerning copyright and accreditation, which might be part of the reason why such principles are not more widespread in the commercial context and in the Web 2.0 of big tech companies. Companies like Google and Microsoft have designed knowledge graphs along similar principles, but quite often without using the open standards defined by W3C. Which brings us to the fact that linked data is mainly adopted in academia and in the public sector and other non-profit spheres. And as a result, there are not any mainstream consumer software available. There is no Excel or MS access for linked data yet. Now, to some of the advantages, I would emphasize the use of URIs or IRIs, because they make it easier to combine data from different sources. And another advantage is the possibility of embedding the data scheme or ontology in the data so that it becomes self-documenting. You don't lose any metadata the way you might do if you get a data dump, CSV dump from a relational database. And finally, linked open data could help promote a more open web and maybe give commercial actors incentive to use the same standards because of the availability of linked open data. So where do you start with open data? I will be careful when it comes to giving any advice on this area, because I'm actually quite new to this myself. But I think it would be a good idea to start standardizing authority data and agreeing upon, and to some extent, agreeing upon what kind of ontologies to use. And another important step is to convert existing data into RDF and provide your own resources and authority data with IRIs that point to a landing page or a RDF file that you make available online. To sum up, we have looked at the origins of linked data in the ambitious vision for semantic web, and I've described some of the basics of the RDF standard that provided a framework for linked data, and I've listed some of the principles that Tim Berners-Lee outlined for linked open data. And linked data can be these principles, or often also used when describing data that follow these principles. And one can also understand it as a less ambitious approach to the semantic web, so we can reap the benefits of linking data without necessarily reaching the machine-readable database, the global database that Tim Berners-Lee envisioned. Finally, we had to look at some of the more tangible technologies that have really realized some of the potential of linked data. Yeah, that was all I had. Thank you for listening.
Thank you very much, Henrik, for this very, very nice and condensed introduction. And we will come to the questions at the end. So this was the starting point for all of us, and now we will jump into examples, country-specific examples, and we will start with the Netherlands. I introduced Alexandra Rowland to you, and I hope that I will see her on the screen with video and sharing her screen, if that is possible.
Yes, I can share my screen, but I don't have access rights to the sharing just yet.
Okay, because you are not part of the presenters. I can open your presentation and click forward, or Cecile, you move Lexi to the presenters.
Oh yes,
it has been done.
Right.
Yeah. Okay, you have the floor, Lexi.
Thank you very much. I think you should be able to now share my screen. Just give me a thumbs up if that's going well.
I can see your screen.
Okay. Yeah, good afternoon. Thank you very much for having me. Good morning. I know for some of you, we're not all in Europe. Yeah, I'm Lexi Rowland. I work at the Dutch Cadastre, and with this presentation, I'd like to take you through an example of our linked open data implementation and what we call the Cadastre Knowledge Graph. Just to provide a little bit of structure to this presentation. So first, I'll just briefly go through who and what is Cadastre, what we do, and what we're responsible for. Then I'll give a status overview of our linked open data implementation, what our architecture looks like, and the Cadastre Knowledge Graph itself. And then I'm going to try and fit in a very quick demonstration on the use of geographical names in the knowledge graph. If I don't get there, or if I have to cut it short, I do have a link to that live demonstration environment. So I'll put that in the chat afterwards, and please feel free to go through that yourself. Just to give you some context on where I sit within the organization, I'm part of the data science team, and our team is then part of the Emerging Technology Center within Cadastre. We carry out data science tasks, of course, but we are also very focused on making use of new and innovative technologies, so linked data, but also AI and machine learning to improve business processes within the organization, and also bring new technologies to production. The land registry itself is the Dutch Land Registry and Mapping Agency. We're in one organization, and our role is the publication and maintenance of several key registers. Our key registers in the Netherlands are well-defined domains and data models, and often associated with a given law, and contain data from that particular domain. The government itself is organized around key registers, and all government data is then defined in a key register. Our spatial data infrastructure developments in the Netherlands are also strongly related to these key registers, and the development of e-government policy is also very much associated with these different key registers. And the organization of these key registers across different governmental organizations is an interrelated system, but they are not always automatically connected. So often you have things that point to other base registers, but they are not, the data sets themselves are not necessarily connected. So that's sort of the starting point for our linked data implementation. As Cadastre, we maintain about half of this picture. And the rest of the base registries are then published by other governmental organizations tasked with the administration of those data sets. Just briefly, Cadastre itself maintains this list of base registers. Just to do a quick translation, the top is the key register, the cadastral key register. We also have the key register of topography and large-scale topography. also the key register of addresses and buildings. So very much geo associated buildings and large scale topography across the Netherlands. And these are all data silos as it stood before we started our linked data implementation. Well, why did we choose linked data as an organization? Well, these are already associated with our ambitions. And in order to achieve these ambitions, we needed to provide the semantics of our data so that there was a shared understanding of what our data means across the whole of Dutch society. What was our goal? We also wanted to ensure that the provenance of our data was very clear to our users, and also to provide information about how our data should be used, where we've made calculations or abstractions, or where we have combined the data. So in other words, we needed to provide good quality metadata. In order to achieve these goals, our data should therefore be findable, accessible, interoperable, and reusable. So very much based on the FAIR principles. And we were really trying to achieve this 5-star data model, which is closely associated with linked open data. So very quickly we came to the conclusion that linked data would be or linked data, the semantic web approach, the technologies associated with these approach would be a good thing to implement within Cadastre. Like I said before, all key registers are sort of independent. They are data silos, and the reason for this is because of the need to organize information across different governmental organizations. In order to provide more certainty to our data and to increase the reuse of our data, we needed to move towards integration and ease of use. Integration and better publication improves the certainty and reusability, because people are less inclined to copy our data and use it elsewhere. And they also understand the data so much better, so then they could then reuse it. This integration needs to be explicitly modeled, published, and easy to use again. And these principles are therefore at the core of our linked data implementation. As Cadastre, we make use of the OGC standards as a geospatial focused organization. But for the non-geospatial person or professional, these are not enough, and we needed to provide more standards in order to improve the clarity of our data. And so we moved towards the W3C standards in order to make our data more accessible on the web. So what types of questions did we want to answer before we started with our linked open data implementation? And this is a good example. So where can I buy a palace with a surface area of more than 1,500 square meters that is also a national monument and is in the neighborhood of Bergenbos in Apeldoorn, the city of Apeldoorn? This information comes from 4 separate data silos: the base register for topography, addresses and buildings, monuments, and the statistical data set respectively. And in order to answer this question, we very quickly came to the conclusion, hey, we need to combine all of this data into one queryable data set using linked data technologies. And so the Cadastre knowledge graph concept was born. Within our knowledge graph, we have the highlighted base registers now included, transformed to linked data and included in the knowledge graph. But before we could build the knowledge graph, we first had to transform the base registers as they stand at Cadastre into linked data and then combine them into the knowledge graph. Each of these base registers are available to look at and to use in our triple store. At the top, you see the link. All open data sets are then open for you to use and query using Sparkle, and also to just browse the graph. In order to create the base registers as linked data, we use the following ETL architecture. So if we move from the top left-hand side, we took the source of the data as a dump and put this into a GraphQL endpoint. Through the enhancer and microservice, we then carried out the linked data transformation. I won't go into too much detail in this presentation, but it basically moved a a native data set into a linked data data set and place this into a triple store and put services on top of this like Sparkle, Elasticsearch, but also more traditional REST APIs. And our data is then open and accessible to applications and users that would like to make use of these base registers as data silos, but in linked data format. But as I said, we need to also combine if we're going to create something like a knowledge graph and be able to answer those questions that are across multiple different base registries. This needs to be combined into what we call the Cadastre knowledge graph. So at the bottom, we have those base registers as silos, non-native linked data. We transform them through that ETL process into the orange layer, and then they are individually available as linked data, but still as silos. We then put a data enrichment and aggregation step and also apply a data model to then build the knowledge graph, which is in the yellow layer. And on top of that, you then see the different services that are then possible on top of the knowledge graph, the Sparkle, Elasticsearch, REST, and GraphQL. Those services are generally targeting developers or data scientists that are very comfortable with making use of APIs. But on top of that, we also have many applications that allow you to browse and access our data without having any knowledge of linked data or of APIs in general. We have various browsers and viewers, but also self-service GIS applications and chatbots, for example, is also a good use case. And also augmented reality applications we now have also working on top of this knowledge graph. I think I still have a little bit of time to do a demonstration, so let me switch to that. What you see or should see on your screen right now is what we call a data store. This is a data story. This is within the triple store that we maintain as Cadastre. And what I'll be very brief, and I'll give you the link in the chat so that you can go through this yourself. But what I tried to show here was the use of geographical names within the knowledge graph. So going through this first sort of table you see on your screen is a live query. If you click on try this query yourself, you will be able to go to our Sparkle endpoint that is on top of our knowledge graph and perform your own query. It looks something like this. This is what a raw Sparkle query would look like, but the result is then a table that provides you with the addresses, labels, and usage functions of buildings in the city of Apeldoorn. This is an input box that you can just change this yourself. For example, we can also change this to Amsterdam and run the query. And you will see that the query was then performed on top of the knowledge graph, and this table was then the result. So we have various addresses with building labels, and here at this top instance is then this building has a industry function, but we also have some living functions if we go lower down the list. This Sparkle query, again, is also performed on top of the knowledge graph and provides an overview of the municipalities, districts, and neighborhoods within the city of Apeldoorn. And if you click on these, you'll see a pop-up that gives the district names and neighborhood names, also based off the knowledge graph, off of the knowledge graph. And finally, we also made the connection between religious buildings that are available in the knowledge graph, and also the link then to Wikidata, which is then a completely distributed a data source. It's not associated with Cadastre at all, but is available then as linked data. And by combining the Bach ID, so the ID for a given building within the addresses and buildings key register, we are able to use the picture that comes from Wikidata and display this on top of knowledge graph data, which is, for example, the building year of this church. And finally, I also made a connection between the Cadastre knowledge graph and the GeoNames dataset, which is transformed by one of our cultural heritage organizations within the Netherlands to linked data. And what you see here in this table is the alternative names as recorded in GeoNames for the city of Apeldoorn by searching for the place name in the knowledge graph and combining this data as a string literal with the GeoNames data set as linked data as well. I think I'm very much over time, so I will stop there. Please feel free to ask me any questions, or also send me an email if you have any further questions or more detailed questions. Thank you.
Yeah, thank you very much, Alexandra, for this this very nice presentation and examples how, if you have combined the data, you can use it in the as linked data, and questions will be put in the chat, I hope, and then we will deal with them afterwards. I see at the moment that there are 2 questions, so please, to all participants, put your questions into the chat and we will refer to them afterwards. So having said that, I would like to hand over to my colleague Falk from Germany, and he will provide you with another example in Germany with the use of linked open data. So Falk, you have the floor.
Oh, thank you very much, Pierre, for this short introduction. I hope you can see my screen and hear me.
Yes, it's fine, Falk.
Okay, thank you very much. So, hello, everybody. My name is Falk Currierhausen. I'm a colleague from Pierre from the Federal Agency for Cartography and Geodesy. And I think we see a good example from the Netherlands to use linked open data in their own application and to interlink to the different registers in the Netherlands. From my point of view, I will give you a short example and implementation approach. In Germany, we create in the project for 2 years. So let's look at my agenda for today. First, I will give you some linked open data background information and the objectives of the project in the BKG. Then I will give you an overview of the queue and development and examples with our BKG geographical names dataset 250. How we solve different problems, for example, the data transformation to RDF, the data management concepts in TripleStore with this geographical names dataset, and questioning methods and networking with other services like Wikidata or GeoNames. And I will give you some challenges, an overview of some challenges from my point of view. And finally, I will give you a short conclusion. So, linked open data. On the right, you can see the so-called linked open data cloud. From my point of view, it looks like a moon. But what you see are the many colored dots. And these are linked open sources on various topics that really identify their data on the web via URL. And they are linked with each other. I come from the spatial data infrastructure in Germany, so it looks very nice in principle. To give you an example for these stores in the linked open data cloud, I hope you can hear something about GeoNames Semantic Web. It's an open source store of the GeoNames. Linked geodata is a representation of an OpenStreetMap dataset as linked open data in the linked open data cloud. Wikidata, it's a representation of the Wikipedia, and also the German National Library in Frankfurt provides linked open data. So the question was, is it possible to build up an own linked open data infrastructure for existing spatial data sets in BKG, for example, our geographical names dataset? In order to provide a prototype of linked data in BKG, various components had to be developed. For example, to enable the provision of linked data, for example, we need a Sparkle endpoint, we need some components for conversation, various geoformats to RDF, and the exploration and reconversation of linked open data into geoformats for their provision. Based on this, the data can, of course, also be visualized. You can browse to the different data sets, but we need ontologies of objects and Sparkle service to share the data. See the figure on the right. And the question, is it possible for the data sets for geographical names in BKG? See also my 4 objectives in the project. conversation, the simplified querying, interlinking, and the enrichment and conversion of RDF data. The first requirement was in the project was the conversion of existing spatial data set from BKG in linked data RDF sterilization, for example, RDF or a turtle format. So for that, we developed our own tool for standard-based data. We can translate Inspire GML dataset in RDF and also shape SV file format prototypically. And we can integrate these RDF data in a triple store. For this, we use the triple store from OntoText called GraphDB, which also enables a very nice visualization of the graph. And here we see it using the geographical names, GN250 with the endonyms and hydrography links as an example. And it is possible to query them via Sparkle. It's the query language of RDF data in the semantic web. And you can see this example query and the result, for example, our persistent ID, the name, and also the geometry in the triple store. That's the back end, but what's the front end? We also create an own front end. This is the name place collections front end with a nice map, with a legend, and with a feature table, which all of the items in our triple store. And if we click on one item, we see detailed information about the geographical names. Here is an example of one item called Hohensulzen with his persistent ID. We have implemented a search bar. We named the geometry and have our BKG top plus background map in the background of this point. And you see all properties and values of the name. And also we use the namespace from GeoSparkle. GeoSparkle as well-known text. GeoSparkle has geometry, the RDFS namespace, and also an Inspire namespace, begin lifespan version, local type, name, and type. And that's also a way to implement Inspire in an additional way. So that looks very good, but what are the challenges? From my point of view, it's a common UI concept. Not only local IDs are required to integrate and interlink different concepts. The concepts must be described in ontology, for example, like the geonames ontology. And this is the link of the documentation. And on the left, you see a part of the documentation. The geonames ontology makes it possible to add geospatial semantic information to the World Wide Web. All over 11 million geonames toponyms now have a unique URL with corresponding RDF web services and other services describe the relations between toponyms. And the ontology for geonames is available in OWL. It's the ontology web language. You can download this as RDF file, and the mappings you can also download this as an RDF file. And each of these items are have an own UI. For example, Embrun in France has an own number, and the RDF you can download this with the second URL concept. And the question of all of our project was, what is the best way to implement such ontologies? Is it on the local level, the municipality level? Is it the national level in Germany? Is it the national level in Netherlands? Or is it the international level, like here, this worldwide geonames ontology? And another challenge we want to solve is the integration of the triple store in standard GIS software. For this, we built up a QGIS plugin. QuantumGIS is an open source GIS, and we want to integrate our own triple store in this linked QGIS. And we built a prototype of a plugin, And we can query not only our own Sparkle endpoint, we can query also the Wikidata, and we can also query geonames in QGIS. And that could be our way to make a better use of this data in the linked in the Triple Store in a standard GIS software. And it's a prototype; it's not a finished this development. So finally, my conclusion from the project. From my point of view, linked open data provides the possibility to use and interlink existing geographical names dataset in Germany in a very easy way. It is possible to set up a linked data compliant architecture. I show you some of that. It is possible to transform existing well-known geospatial standard coming from ISO, OGC, Inspire into linked open data. And we find a Triple Store for the provision of linked spatial data and query them via GeoSparkle very easy. But in the future, the challenges must be solved. For example, to integrate this Triple Store's linked open data sources in standard GIS software back again. Or another challenge can be to build up a common ontology in the UN, like geonames, but this discussion could be a part of the discussion after the presentation. Finally, with the examples of the BKG geographical names dataset we use in the project, we have shown how our existing spatial datasets can provide as linked open data and benefit to a greater extent and linked to other data in the semantic web. So that was my short presentation, and thank you very much for your kind attention. Thank you.
Thank you very much, Falk, for this very nice presentation as well. Another example where even the Spatial Data Infrastructure Initiative used the linked open data concept and showed that some good things can happen with linked open data. And now we will have some questions, as I said, later on. Some are already in the chat. And now I'm very pleased to hand over to Peter Gammeltoft, because he will show us, are we blessed or cursed with the linked open data concept? And he will try to enlighten us and to motivate us to transfer all our data into linked open data. Peter, you have the floor.
Thank you very much, Pier Giorgio, and thank you for letting me talk today. It's a bit of a daunting task to talk about being blessed or cursed, but I would say that we are probably neither. And let me just show you why. I'll just begin my presentation now, and if you have questions, we take those towards the end. You've already heard something about the basic principles about linked open data, and also you have you heard about or you've seen a couple of implementations as well, and this is very encouraging that we have these. Let's just start off again with the definitions, because we really are working with two types of data that are really closely linked together. One of them is linked data, and that is the set of design principles we have seen shown today, which are principles for sharing machine readable and interlinked data via the internet. Linked open data is an extension on this. This is where we combine linked data with completely freely available data and make linked open data, of course. And we can see this as being a virtual data cloud that can be accessed by anyone that are authorized to do so. And you can also add data on top of the data of the data without disturbing the original data source, which is quite handy when you're talking about data that can be used and reused for all sorts of different purposes, because there will be some usages that are not significant for one field, but which are important for another branch, either in business, on science, or in administration. Returning to being best, whether we are blessed or cursed as a technology, it's relatively new, and that can be both a blessing and it can be a curse. Being a new technology means that there can be quite a lot of interest in it. The curse can also be that there's not a lot of knowledge about it. And for quite a while, we didn't really have any standards, and we didn't really have any best practices either. But recently, the World Wide Web Consortium have published best practice recommendations to their linked data note. And this gives us the possibility actually to use this as a framework for how to structure our data so that we have data that are comparable. Then there are also today a number of ontologies in use, and this is really good, but it's also a challenge because different ontologies see data in slightly different ways. So I think the challenge in the future is to actually define which ontologies are suitable for geographical names standardization, and how they also can be used in all other walks of life at the same time. Maybe this is a bit redundant because you've actually seen why we should use linked open data principles in the first place, because we saw some really good examples of this just before. The data, as also the first speaker said, it's easy to retrieve and easy to remix your data, and you have consistency across all metadata providers. And it's using standard web protocols. So basically, turning your data into linked open data or linked data means that you are actually using, you're actually complying to a standard that others are complying to. So you're actually catching two situations in one move. But I think the most important is how linked open data facilitates, and how it facilitates the almost eternal extension of one's data model. You can basically rework your data model all the time and allow for whenever new features come in. And this is quite important. Just imagine that you have a data set or a data model that conforms exactly to how official society wants geographical name standardization to be. But then there's a change in the law, and you have to do a slightly different direction. If you have a relational database, you may have a lot of problem actually adjusting the data model to that. With linked open data, it's much more easy to change or extend the data model to the demands, and it's much easier to update your data model all the time. And this allows for much more efficient data integration, and not least of complex data, but also how to analyze data. And we saw a really good example from the Netherlands for this. This is one of the reasons why they chose this technology. And although we have a problem with scalability, as Henrik said earlier, linked open data are able to handle huge data sets from a number of disparate sources and to link them together. We do have a number of challenges, though. Going over to linked open data means that you have to do a paradigm shift within your organization. You have to make quite a large change to how you see and manage data, and you'll also need new expertise in order to manage linked open data. Although it's definitely not impossible to take your existing group of developers and then train them to use linked open data. We had a workshop here at the language collections last week, and within 3 days, people that had no prior knowledge as such of linked open data, but were experts in relational databases, were capable of actually making relatively simple data exchanges through a common data model. So it's absolutely possible, but there is a steep learning curve, and you have to be aware of that. And that's also an extra cost on your organization, of course. More importantly is giving your data out as linked open data or linked data is as a means of decentralizing data, and also means that your data can be subject to scrutiny and questioning, and you may be facing questions about the how good your data are. Another thing is that you need to have your data to be consistent, so it can be structured and classified correctly. And the most important thing can be that opening data has not been a priority for national mapping agencies earlier. So if you go from a non-open principle to open principle, you have to be aware that you have to spend quite a lot of effort on actually making your data ready for opening, and that's actually cleaning the data in quite often, and that can be quite resource intensive. And of course, you'll always face criticism when you put something out, and that can be harsh to suffer, especially if your data sets are not complete, or if they are inaccurate because of a wrong supply of data sources, something like that. And of course, just getting into LOD can be difficult. So, in conclusion, are we blessed? Well, not really. We're not blessed, but we're not entirely blessed, if there is such a concept of being almost blessed or nearly blessed. But what is actually known is that we don't really have any consensus about what ontologies to use among national mapping agencies. We have not that many proof of concepts yet. We saw 2 today. And I'm sure we can find a good handful more at least, but that's about it. So we don't really have much to mirror ourselves against and our own data against. And then we also have to learn all the new design principles behind linked open data. But once we've done that, we will have sector crossing technologies that allows for integration into all other walks of life. And we will also be able to share data with big tech. Now, Henrik did say that big tech in some instances are using linked data, but they're not complying necessarily to the worldwide consortium principles. But at least we are working in the same direction, and hopefully, as was also said, we will be able to lure big tech into actually using our data because it's available for them and it's for their open free use. Thank you.
Thank you very much, Peter, for this excellent overview on the challenges and also on the opportunities, and what is still missing and what the opportunities are. Thank you very much for that. I would like to invite now all speakers to switch their video on and to open now the question and answer session. We have about 20 minutes, and then Susan, please switch your video on as well. We'll give some closing remarks. So I would like to say here, thank you very much to all the speakers. For me, it has been again very interesting and exciting. And let's look at the questions. And in the chat, I can see one question by Andreas Hadjiraftis, which has already been answered by Lexi. So there is no question left from Andreas, I hope. And there is one general question by Gerhard Rampel, our colleague in Austria, on the ontologies. Is there an established ontology to be used in official place names data? And I have understood Hendrik referred to that, Falk, I guess, referred to that, and also Peder referred to that there are ontologies there, and some are in use. And is there any official body, for example, UNGEGN, to be able, to evaluate and assess those ontologies or to contribute to those ontologies? That's a general question, I guess, to all of you. Is there an ontology you would recommend? Falk, you mentioned the geonames.org ontology, and Peder, you mentioned 3 others. So what is your view on that? Please, first come. Peder, start.
I think the challenge is that it seems that we're using different ontologies, all of us. For instance, in our organizations, the language collections, which is not as such a national mapping agencies, we feed our data into the standardization process. We are using something called CDOC CRM, which is a more like a cultural historical based ontology. Then there are others, and perhaps I don't know whether we should venture into have a UNGEGN ontology. I don't think that would be a wise thing, but it's certainly a possibility. But what do you others think?
Also, in our project in Germany, we look in different ontologies. For example, linked to geodata has also good and worldwide names, but they're based on OpenStreetMap. And also Wikidata, also a worldwide ontology, but it's based on crowdsourced Wikipedia. And also in geonames, it's not an official. The only official one we use is an existing Inspire ontology. Its geographical names is also Inspire Annex 1 theme. And this is only in the region in Europe useful, not in Africa or not in US. And it's a good question. Is there a common ontology in the whole world? From my point of view, it could be. But it's also a discussion what's the best.
Okay, thank you, Falk. Maybe Lexi or Hendrik. Lexi first.
Yeah, with our first implementation of the knowledge graph, we tried to use schema.org as the overarching data model, but we quickly found that it didn't quite semantically capture everything that we were trying to describe. So with this new, the knowledge graph that's now in our triple store is using a new data model. It's not a complete standardized data model, but something that we're slowly building based on different layers of standards. And we work very closely with our standardization authority in the Netherlands, GeoNovum. And they are working on providing this overarching, it will be in the end be an ontology that tries to capture semantically, which is really important if you have a key register that's defined by law, that everything that is semantically defined well in an ontology. So my answer to do we need one that everybody can use? I don't think that that's practical. I think that there's too much. If you have to think about a law, about what you're trying to capture, what you're trying to visualize, for example, across multiple different regions in the world, that will not come to a single ontology. What's more important is that where things do overlap, where they do link, that those links are well defined.
That would mean, if I have understood that correctly, that for your implementation in the Netherlands, you have adapted a certain ontology for your specific use cases or your specific data sources.
Yeah, so it's in the development phase, the ontology, and it's very much defined on the base registries themselves, the data sets that are used in the base registries themselves, and how to semantically model those to come together in an overarching data model.
Okay, thank you. Don't know, Susan, Henrik, you have some views on that?
Yes, I would say that I support the idea of not creating an overarching new ontology, because then you always end up creating new ontologies, and I think the better approach would be to make sure that it's easy to convert between them, or to have links between them.
Mm-hmm. Susan, we can't hear you. I don't know if you wanted to provide a view on that.
I was just nodding really, Pier Giorgio. I think absolutely Lexi's spot on there. There's really so much going on in that space. I certainly don't have the technical expertise of our speakers today, but my understanding definitely is that the key is to develop the ontologies and make sure that they are published, make sure that your data is very clearly explained and things are published so that it is reusable and connectable. But yes, one great big ontology for all sorts of UNGEGN place names, I just don't think would be possible. So yeah. I think Lexi's done a great job of explaining that. Thanks.
Yeah. Nevertheless, if we would now, because this webinar has was supposed to be a starting point to think about what linked data can offer as a concept, as a method, and we learned from the Netherlands and from Germany that there are big opportunities. We learned as well that there are some challenges. But what could we tell countries, national mapping agencies, which are not yet in the position to have an application or an implementation, to invest money and resources? Because I can imagine, Lexi, that in the Netherlands you have invested a huge amount on resources to convert your data model and to transfer your registers into linked open data.
Yeah, I think where we've been quite lucky is that this development has come from an innovation, like, let's say, corner of our organization. So we have a lot of freedom to experiment with new stuff. If that doesn't work, throw it out, start again, or move it to production. So yes, a lot of resources were dedicated to building the knowledge graph and hopefully moving that. It's in the roadmap to now move that towards production. But what would my advice be? I would say start small, try a small project, see if that works, present that, lessons learned, then try and expand. Don't try and implement a large scale movement to produce everything into linked data. I think the organizational mindset change that takes is slow, and if you start small and prove that it works, you'll slowly bring everybody on board in your organization to make that shift if it fits within your business roadmap or your ambitions.
That's a good point. Thank you very much for that, because I'm also always thinking, how can I convince my director general, to take the decision to transfer all the data into linked open data, but I do not have any I do not have very good arguments for that, but to establish a project like Falk mentioned as well within a spatial data infrastructure, and to invite also the research to contribute to that, and to then with a small project show that things are possible and different things are possible when the data is linked. That I think it's a very important thing, and can help also others, to overcome with all the obstacles. Because I think Falk mentioned the main obstacle is that the geographical names experts, and this community is more or less a geographical names expert community. They do not all have technical, very high technical skills, and so you need some technicians, linked open data experts to work with. And this link has to be established somehow with the research, with universities, or you are lucky, Lexi, within your organization, you have a research unit. And so that might also be something we can think about. Who are the links to establish on a national level to establish a small project? That's good. I don't know if there's another question. I see there's one question with regard to the name of Mozambique in a local language. I don't think that this is a linked open data question. I would like to know about the name in our local language. Well, I can't provide an answer to that. And then there is one question: developing the applications that we have seen, was it necessary to use advice and guidance from experts outside your organization, from university, for example? I don't know if Lexi, Falk, you can provide an answer, and then of course Peder and Hendrik, you are from the university. I guess you can you can say more about that. Lexi, maybe was university involved in your project, in your environment?
Yes, very, very much so. So I myself am from the University of Twente. As a PDN student, the team lead for the data science team is also associated with the University of Twente. And then our linked data experts either come from academia or are still working in academia. So we, as an organization, we have a very close link to our universities. And yeah, they were very central to our linked data implementation. Yeah.
Thanks. And Falk, in Germany?
Yes, we have also contact to the universities, and they are a part of the project with our questions. It was also a part of my PhD, so it could be a way to build up the link from the university to the federal agency. And I make this 2 years project, but I hope it's only the start of this topic in PKG. And I hope here we can make some more questions and solve more problems. I show you, or make some implementations together.
Yeah, and Peder, Hendrik from the university side. So you would like to jump into the spatial data infrastructure, the official one? Yeah, that'd be great to be able to exchange data between, because we have so much overlap between our data and also our perspective. So it would be great if we had a more direct access to data through linkage. Yeah. Perfect. What do you say, Henrik?
Yes, I agree.
Susan, can you provide a view on the Australian situation? Is there the research, the universities, are they involved? You're muted.
Yeah,
I guess.
Giorgio, I think from the Australian situation, and I was going to sum up with a little bit of this, and I'll tie a little bit into your previous question as well. in that it's definitely not the geographical names authorities that have this expertise, certainly by any means. It's in the academic space and certainly the research space within sort of small niches of government. So finding those connections, I can't even recall how we found those connections, but they did just happen. But I think something that was really, really important for us, and something that is probably a really valuable takeaway for those of us in the geographical name space, is that the precursor to ontologies are glossaries and dictionaries and definitions of your data, and these can be in simple analog form. So the knowledge that we have and the capacity that we have in the geographical names authorities is to be able to explain that data. We don't necessarily need that technical knowledge that we've heard from our speakers today. We can present that in quite a simple, digital or even analog form. And of course, the other part of that is making sure that your data is accessible and available and out there. And certainly from the Australian situation, we were very fortunate. We had both of those things. And then those research organisations that did have that linked data technical capability were able to pick that up and run with it and do that sort of work. So that's probably a slightly different approach, and certainly not as advanced as you've heard from Lexi or Falk today. But that's something I think for all of us to think about. We don't necessarily need to have that ourselves intentionally, but it certainly does seem to be in that academic space. I think it's a new thing still, a little bit researchy and in that new space. So I think we've got to be looking into the universities and academic space.
Yeah. Thank you very much, Susan, for that clarification. I see that there are two more questions, or one comment and one question in the chat. So one referring to me, that Andreas from Cyprus mentioned that he believes that this issue needs to be handled by a team of experts such as IT, geospatial, and academia. That's what you said, Susan, and confirmed. And Lounis from Greece asked the question: would the promotion of linked open data and its concepts lead to changes in the existing operational data structures and data definitions in the databases? I look in your faces now, and I would say yes, definitely. But you should give the explanation. I don't know if Lexi, Henrik, or Falk would say something on that. Ladies first, maybe.
Yeah, I think the short answer is yes. Of course, if you are going to promote linked open data, the structure of the data is then very different to relational database structures. But I'm not sure if this is where the question was leading, but it doesn't necessarily have to be in one big go. Like I said, you can start small, and we have both relational and linked data and the knowledge graph all available in our organization right now to slowly be able to transform people, transform the mindset of people towards linked data. But linked data is not always the answer. So there is still a place for relational databases, of course. So in promoting the concept, I think you also need to answer the questions of why. Very important.
Yeah. Yeah, thank you for that. I don't know if there's something to add from the others to that. If not, I would have, before you conclude, Susan, you have some minutes left. I think at least 5 minutes left. I would like also to highlight one thing. I think you, Falk, mentioned that a prerequisite for linked open data is also to have the data which is already there with persistent unique identifiers. I guess that this is something, and we have also colleagues in my working group on geographical names data management who wanted me to highlight that this is also something which is not you know, it's not a clear-cut case in every country that you have these persistent identifiers for the geospatial data, particularly for the geographical names data, and that this is something that this is the prerequisite for linked open data as well. And then my question, one more question I'm interested in, Lexi, to you is, you have now a system which is operational and where you have already customers using linked open data, and if yes, where do these customers come from? So what are the domains?
We have a range of user groups that we target. So the students are a strong user of the knowledge graph, but we've also made commercial connections with we have a portal in the Netherlands called Funda that helps with searching for housing, either renting or buying. And we did a small project with them where we delivered their data. So there's really a big range. I think anyone interested in any sort of integrated question is then our customer and can make use of our knowledge graph, either from the service level, so making use of the APIs to build applications, or make use of the applications themselves. Okay,
thank you very much. Good. So I do not see any further questions in the chat. Then for the closing remarks, I would like to hand over to you, Susan. And then before we conclude the webinar itself.
Okay.
Susan.
Thank you very much, Giorgio. Well, everyone, hello. As Giorgio introduced before, I'm the Australian representative on UNGEGN, and I'm also a member of the working group on the geographical names data management. So that's where I've been working alongside Giorgio and others for the last couple of years now to really help UNGEGN effectively find its way with this new technology. I'm also co-vice chair of UNGEGN at the moment, so it is on behalf of the whole expanded Bureau of UNGEGN that I have the honour of doing a quick summary and providing the thank yous today. So first up, we heard from Henrik, who provided us an introduction that really wove together some background and the fundamentals of linked open data. I think this was a really helpful starting point. And Henrik also let us know right up front what some of those challenges and advantages are with linked open data. So that was a really helpful, I think, founding opening statement for us. So thank you, Henrik. To Lexi and Falk, I think some wonderful, if not quite advanced examples from your respective agencies of really some of those wonderful advanced opportunities, I think, that linked data is able to offer us. I think it's quite helpful for many of us that are probably not quite even close to that to really see some of those real world examples. And I did see, Lexi, that you did share some links and some further information as well. So hopefully, Falk and Lexi, if you haven't already done so, have a look in the chat and find your way through some of those links if you want to go and have a little bit more of a look at some of those examples there as well. And of course, Petter, the difficult challenge of working out whether we are blessed or cursed. I'm not, and didn't really get an answer for us, but that is completely understandable in that sense. But I think a really helpful, almost a summary as well from you, Petter. So thank you very much for that that wrap up there. So Henrik, Lexi, Falk, Petter, a very special thank you for sharing your time and knowledge with us today. It's really, really very much appreciated. And of course, Giorgio for moderating, I think, quite a good session. Hopefully everyone has gotten a lot of value out of this today. Giorgio asked actually during that just last panel discussion about how we might start and how we might move on from here. And I think from my observations through our discussions to date, and also the presentations that we've heard today. There are really sort of three recurring areas that need attention, or three key messages that keep popping up all the time. That's the need for vocabularies or ontologies that describe the data, the essential data accessibility issue, and of course the unique resource identifiers that were mentioned before. So as I mentioned a little bit before, even if you don't necessarily have that technical capacity just yet, I think there is scope for some of us to become what we might call linked data ready, by actually making sure that our data is well described and clean, and published at least in that sense. So that's something, if you're a little overwhelmed and lost by the examples that were shared from Lexi and Felt today, I think that there is really a lot of scope for you to really sort of step it back and let's look at it as linked data ready rather than linked data implementation or pilots as well. So that's just something that I wanted to mention for those that may be wondering exactly how to get to that kind of point. So what's in it for UNGEGN and our experts? Well, seemingly quite a lot, but as Peter's pointed out for us, we also have some way to go to really do a lot more testing and that kind of stuff. So we really encourage you to continue building awareness and understanding around this linked open data topic, and of course sharing your learnings as well. How? Well, I think the best and the first thing that we would ask of you is to seek local connections within your country. This type of technical expertise that we've been talking about today, I think it's well recognised it's not a common skill set within geographical names authorities. Yet it's the geographical names data that it's so often fundamental to building useful linked data ecosystems. Equally, I think the nuanced nature of geographical names and the various ways that names data is structured can be challenging for those outside of names authorities, particularly those that might have the linked data expertise and who might be wishing to use that. So it's really wonderful to actually see that we have a lot of attendees on the call today that are not only from geographical names authorities, but also from our geospatial authorities and importantly, research institutions. We really must work together on this. So I'd encourage you all to seek out your national and your regional colleagues and make those connections locally to continue the discussion. Secondly, for those of you who are UNGEGN experts and who will be hopefully attending the session in May in 2023, I'd encourage you to start thinking about papers to share any additional examples that you have or experiences that you have around this space in linked data. And thirdly, let us know here, so through Pier Giorgio, through the Secretariat, the Working Group on Geographical Names Data Management, let us know what else we can do, if we can assist in any way further to sort of help you on that journey. So they're probably the three takeaways that we would ask from you today. Hopefully that is not too onerous, and we would encourage you to consider and continue these kind of conversations. Before, and one final request, I'm not sure if it has popped up just yet, but please pop into the chat before you log out of the call. There is a link there to our evaluation form, and we would very, very much appreciate it if you could take just a few minutes to fill it out and let us know what you thought of the discussions today. We really appreciate your time. So thank you again.
Yeah, thank you very much, Susan. And no more words from my side, apart from thank you very much to the speakers, to Henrik, Lexi, Falk, and Peter. And have a nice afternoon, nice morning, a nice night from everywhere on the globe. And see you next time at the next webinar of UNGEGN. Thank you very much. Stay safe.
Thank you.
Thank you
It was
very
a pleasure.
much.
Thank you. Bye.
Thank you very much.
Cecile, can you stay online? And Susan, maybe you for just 2 more minutes?
Thank you. Thank you.
to cross-check here.
Thank you.
You're still recording, Cecile. Did you want to stop that before we have a chit chat?
Well, lots of people are still on.
Yes. I counted about